Good afternoon. Well, you can't say climate doesn't make the headlines, huh? So we are proof positive that the issues and challenges that the Earth Institute is working on are unfortunately becoming more and more the centers of attention, so much that they can blow off presidential campaigns and all other news and leave this city stranded for many days. So I want to thank people for making it here. I know some have bicycled in from Brooklyn, I understand, and others have managed with difficulty. But we have a tremendous number of fascinating papers that our fellows will discuss this afternoon, and I think a good chance to reflect on recent events as well in the context of climate change and the issues, infrastructure, which are all topics of the presentations. So we're going to start with a number of related themes. The first is on optimization of water, energy, agriculture management under climate and population change. So what could be more appropriate? Tess Russo will start us off.
Okay, let me start. So you know my title. I'm a first-year Earth Institute fellow, and so I don't have conclusions for the project that I'm working on, but I'm going to give you a little bit of background on the work I did before I got to the Earth Institute and describe the project that I'm starting to work on. So I'm going to start with this 1,000-mile perspective of our water resources on Earth. The sphere there represents all the water on Earth, so that's all of the fresh water, all of the salt water, all the frozen water, all of the water in the atmosphere, and biologic beings. We can break that up into the liquid fresh water, those two little spheres to the right. Sorry. Does that work? There we go. These two spheres here represent all of the liquid fresh water on Earth, and this larger sphere, which is about 97% of the liquid fresh water, is groundwater. And then this tiny sphere here is all of the water that is in lakes and rivers. So the 2 points that I want you to take away from this figure is, one, that we don't have a lot of fresh water. We have limited resources, and of that, groundwater is a very important fraction. So for my dissertation, I looked at hydrologic system responses to environmental change under multiple environments, multiple case studies in California. I modeled wetland restoration downstream of a reservoir. I looked at the impact of forest fire on, this doesn't work, forest fire on stream bed exchange processes in a salmon habitat. I looked at an area that had severely overdrafted aquifers and tried to identify locations for managed aquifer recharge. So how do we put water back into the ground intentionally? And then I looked at quantifying changes in extreme precipitation in the San Francisco Bay Area. So this was sort of a wide variety of environmental changes that can both be climate-related and human-related. And these types of changes are influencing hydrologic systems at an unprecedented rate right now. And we need to understand these changes and understand the response to these changes in order to operate within the new conditions. So basically the summary from all my dissertation work was that as these changes continue to impact hydrologic systems, we need more projects that link fundamental scientific research objectives with effective and efficient management and restoration strategies and practices. So that brought me to the Earth Institute. And now, some motivation for the work that I'm doing now. This figure shows the unsustainable groundwater use in the world. So you remember from that figure of the globe, where I said we have a lot of groundwater. Well, we do, but we're using it faster than we're refilling it. So this figure shows unsustainable groundwater use. So all of the colored areas represent in millions of cubic meters per year water that is being taken out in excess of the natural recharge. So, and you can see I'm equating unsustainable groundwater use to unsustainable food production because that's the primary use of this groundwater. And if you look at the United States, we can see the breadbasket region has a lot of unsustainable use. The Central Valley of California is red, and the area that stands out most on this map is northern India, the Punjab region, which is where my new project will be based. And so since the Green Revolution in India, they've increased agriculture and are being able can provide food for everyone in India, which is great, but they're doing it in a way that is not sustainable. And in Punjab specifically, they've increased the total area of irrigated crops, and specifically rice. So they're planting on the figure here on the x-axis, it goes from 1970 to 2005, and on the y-axis on the right side, it shows the area of rice in thousands of hectares. And you can see that the area has gone from 200 to over 1,000, or a million hectares. And rice, it's important that they're growing more rice because rice is a very high water demand crop. So they're not growing something that is sort of within the confines of the resources that they have. They're growing something that they really can't support. And because of that, the water table depth is increasing. That's what that blue line that is going down over time, that's the depth to water. So this is the problem. And my project is trying to figure, sorry. That is, and this figure is very conservative. So basically what they're seeing in Punjab on average is 0.4 meters per year and up to a meter per year in some areas, which is quite significant, especially if you're building a well. You don't have to rebuild that well every 10 years because, you were saying rising in the India Punjab side? Okay. Mm-hmm. Yeah, they do try to justify some of it as leakage from canals. There really isn't that much. The water levels are going down, and oh, okay. Okay, I don't know about that, and I assume that's climate related. In the early 1900s, the water levels were lower. Okay, I wanna see that then, because I don't understand that. But okay. Okay. Yeah. No, sorry, that's not true. They are growing a lot of rice in Punjab. I have. They are growing rice in Punjab. They shouldn't be. You're right that they shouldn't be. Okay, I don't know what to, it's not true. Okay. Sorry, I'm like fighting a bad cold too. Okay, so my potential solution to dealing with this is to a five-step problem or five-step process. The first is constructing a hydrologic model. In ModFlow, this is a schematic of what part of the model would look like. It's a 3D numerical model, and the input comes from the stratigraphy of the region, which we get from 750 boreholes, and then we would establish the initial water conditions based on current water levels, establish the water availability. The next steps would be to define land use, crop selection, and then the associated water extraction rates associated with those land uses. And then we'd be using this farm process package, which is a new USGS code that goes along with ModFlow that allows you to alter or to basically program in decision making based on crop type that will water certain amounts according to the climate conditions and the available water. And so the last driver of the model is climate, so we're going to use climate projections for the region to be able to drive this model. The next step is to define adaptation strategies, and we'd be looking at both the farm level and at the government level. So examples of farm-level adaptation strategies could include irrigation management, like if you installed sensors in the field to inform farmers of when they should start and stop irrigation, crop selection, so growing crops that are appropriate for the climate in that region, not rice, growing different wheats and vegetables. Managed aquifer recharge, which was one of the projects that I focused on during my dissertation, which is basically where you're assigning some part of your field to enhance the natural occurring recharge in the region. Through percolation ponds, yeah, so not pumping water into the ground, a passive recharge method. And then at the government level, modifying the electricity subsidy system, changing the crop procurement method, so changing how pricing is assigned to how they're going to buy crops from farmers and where they might assign crops to be grown geographically throughout India, and then changing or making the dam releases more reliable, so making surface water a more reliable source. So once we have those adaptation strategies defined and the hydrologic model, I'm going to build an optimization model, which will include the hydrologic system as well as energy usage and then economics, so the costs of energy and the profit from crops. So what you would do in this model is run it for the given adaptation strategies within the hydrologic model and then account for energy and economics afterwards. And so you would get in the end the hydrologically sort of estimated solutions and then paired with the feasible economic solutions. So, and then this could be redone under various climate scenarios. So we could take like 3 of the IPCC projections and run it for each of the 3 and determine how those strategies change under different climate scenarios. So once that's done, we'll have these recommendations that we can make at both the farmer and government level. And we're working with researchers at the Punjab Agricultural University, and they have a lot of relationships with both the government and the state government, the farmers and the state government there. And so we'd be, hopefully, in addition to making recommendations, actually implementing some of these solutions. And then lastly, which is a step that is often left out of most modeling studies, is to go back and monitor and evaluate the results of these implemented strategies after seasons, after growing seasons, to figure out what's the actual efficacy of these adaptation strategies, what's really working and what isn't. And that sort of turns it into a long-term study, but I think that's required to solve this long-term problem. I hope I stayed within my time. Thank you.
My name is Astrid. I'm also a first-year fellow. The research I want to present is joint work with Scott Barrett, and I'm glad he's here especially as it was quite hard to get here from Brooklyn. Our goal was to learn more about climate negotiations. Why do they consistently fail, and what role does scientific uncertainty play? But let me take one step back and say something about the traditional model. Climate negotiations have been traditionally modeled as a prisoner's dilemma. So this is a situation where there is a conflict between collective interest and the individual interest. So collectively, countries are better off reducing emissions, but a single country has only little incentive to do so. But the traditional prisoner's dilemma ignores the possibility of catastrophic events. And somehow this is nice to mention 3 days after Sandy. So the question is, do dangerous thresholds in the climate system affect the incentive to cooperate? So here's an example for a game that includes catastrophe. This game is very simple, but it does tell us something very important about incentives. So we have 10 players, negotiators, if you like, and they have an endowment in form of poker chips. So each player has 10 black poker chips and 10 red poker chips. And all the players can contribute their chips to a joint account. Or they can keep their chips. What matters for this decision is the payoff. The payoff here, this is for one player. The payoff is in euros, not in dollars. You will see later why. So a player gets 10 cents for every black chip capped and €1 for every red chip capped. So the chips represent the costs of emission reductions. So the black chips are a low-cost technology and the red chips are a high-cost technology. Every player gets 5 cents for every chip contributed to the joint account by anyone. It doesn't matter who. So this can represent the benefits of avoiding gradual climate change. And every player finally loses 15 euros if fewer than 150 chips are contributed. So this represents catastrophe. The impact is 15 euros, and the threshold is 150 chips. So what is the best the group can do in this game? The best is to contribute 150 chips and to avoid catastrophe. So for example, if everyone contributes 15 chips, if you do the math, everyone gets 12 euros and 50 cents. What is the best a single player can do? It depends. So suppose everyone else gives 0, then the best you can do is also to give 0, because a single player cannot avoid catastrophe. But if everyone else contributes 15, so 135 in total, if you contribute 0, then you save your chips, but catastrophe occurs. So the payoff is 275. If you contribute 15 instead, catastrophe is avoided, and you get 1250. This is much better. Okay, so what is best for a player depends on what the other players are doing. So this is not a prisoner's dilemma. This is a coordination game. So if you want to put it very simple, a prisoner's dilemma has a unique bad equilibrium, and the player's task is to avoid this bad outcome. In a coordination game, you have multiple equilibria, and one of them is good. So the player's task is to go for this good equilibrium. And once you are there, no one has an incentive to deviate. So the incentives in these two different games are very different. So in this sense, catastrophe can help cooperation. Uncertainty. Of course, there's a lot of uncertainty about catastrophic events and about thresholds. So a very important question is what happens under uncertainty. So we distinguish between two types of uncertainty. One is about the impact, and one is about the threshold. Okay, let's look at the impact first. Assume the impact is not 15, but something between 10 and 20. If you do the calculations again, you just have to replace the certain impact by the expected value. If these two values are the same, behavior shouldn't change. So impact uncertainty doesn't matter for behavior. Things are a bit more tricky for threshold uncertainty. So assume the threshold is not 150 ships, but something between 100 and 200. What is the best the group can do in this situation? The best is to contribute 200, 20 for each player, to eliminate the risk of catastrophe. Everyone gets 10 euros then, and the total payoff is 100. What's the best a single player can do in this situation? So if everyone else gives 20 and you give 22, then you get the 10 euros. If you instead give 19, then you do the calculations again, and you can see that a player gets 1080. That is more. So why is that? If a player reduces the contributions from 20 to 19, it saves one of the expensive chips, €1. The probability of catastrophe increases, but only by a very small amount, from 0 to 100. So the costs that are saved are higher than the reduced benefits. So this is a prisoner's dilemma again. So threshold uncertainty turns the game back to a prisoner's dilemma. Okay, here's another but. The theory assumes that all the players are rational and they care only about their own payoff. It also assumes that the players are risk neutral. So what happens if real people play this game? Would they really allow catastrophe to happen? We have tested it. So we did an experiment with 400 students in Germany. This is why the game was in euros. We had 10 players per group. We used all the parameters I just showed you in this very simple example, and we had 4 treatments, 4 games. One with certainty as a reference, one treatment with impact uncertainty, one with threshold uncertainty, and one with uncertainty about both impact and the threshold. Before our participants could choose their contributions, they could make non-binding announcements. They could first suggest a group target, what the group should do, and second, they could pledge what they themselves intend to contribute. So they could announce targets and pledges. These are the predictions derived from the theory. So in the certainty treatment and the impact uncertainty treatment, where the threshold was known, we expect that the players or that the groups contribute 150 chips, that they coordinate their contributions, and that they avoid catastrophe. In the 2 treatments with an uncertain threshold, we expect that the players do not contribute any chips and they do not avoid catastrophe. Okay, so what happened in the experiment? This figure shows the probability of catastrophe for all the groups in the different treatments. So these 2 treatments are the certainty treatment and the impact uncertainty treatment. There were only 2 possible outcomes. Catastrophe either occurred or not. So the probability was either 0 in blue or 100% in red. So you can see in the impact uncertainty treatment, all 10 groups managed to avoid catastrophe. 8 of 10 groups managed to do that in the certainty treatment. Catastrophe occurred in 2 groups. What happened in these groups was that one person in each group pledged to give 15, but then gave nothing. So these groups missed the threshold by a small amount. It's difficult to say why these 2 persons did this, but the other group members were not very amused. Anyway, only 2 out of 200 students behave in this way, and the difference between the two treatments is not statistically different. Okay, so what happened with threshold uncertainty? A lot of red. So the first thing to notice is threshold uncertainty makes a huge difference. 9 and 7 out of 10 groups had catastrophe with certainty. So they contributed less than 100. Only 4 groups reduced the probability below 100%, and the most successful group reduced it to 80% only. Okay, this figure shows the difference between the announcement and the action. So the blue bar shows the announced target, the red bar shows the sum of the individual pledges, and the green bar shows the sum of the individual contributions. So these are, again, the two treatments with a certain threshold. You can see everything is quite close to 150, and the players did what they said they would. They didn't in the threshold uncertainty treatments. So you can see that here they contributed much less than they said they would. It is also interesting that they didn't propose a target of 200, although this was the optimal amount for the group. The reason was that they saw 200 is out of reach. So they proposed a smaller target because they thought it's more credible and so more likely to stimulate contribution by others. And this is a summary. So what happened in the experiment? With threshold uncertainty, people knew they should go to 200, but they proposed less than this. They pledged less than what they proposed, and finally, they contributed less than what they pledged. So for those of you who follow climate negotiations, this may sound familiar. So let's have a very brief look at the latest negotiations. The 2009 Copenhagen Accord established the famous 2 degrees target. The Cancun Agreement accepted this goal, but also called into question if the 2 degrees target was enough to avoid dangerous climate change. The Durban Conference noted that there is a significant gap between the pledges and the goal. So we do not yet know if countries will fulfill their pledges, but this experiment suggests that there is a risk that countries end up emitting more than they pledged. Okay, so this research can explain why negotiators want to have a threshold and why they want to have the threshold determined by science, because a credible and certain threshold could help cooperation. The trouble is that nature gives the threshold, and the threshold is uncertain. And to a large part, the uncertainty is irreducible. So as long as we have this threshold uncertainty, something like a 2 degrees threshold will not help us very much. So we do need other strategies to change the game. There have been suggestions how we could do that, most notably by my co-author. And this experiment shows that changing the game is really essential. Okay, so this experiment that was published last month in PNAS, and this experiment distinguished between certainty and a very high degree of uncertainty. So another question is, what happens with a lower degree of uncertainty? So this is ongoing research, and I may tell you at the next symposium. Thanks.
Okay, so again, I'm a first-year fellow, so my presentation is really going to focus on my research interests and illustrate that with a few examples from my PhD as well, and then move on to my research that I'll be hoping to do over the next couple of years here at the Earth Institute. Does that work? Okay, so my general research interest is to look at the links between environment and human development and poverty, with specific interest in exploring the use of satellite data as a means to estimate some of these indicators of poverty. And where the idea comes from is that poverty is more than just a numerical financial value. Now, the big financial one is the $1 a day per person, which is the sign of extreme poverty. Now, that's very important, but there are other components of poverty as well. Some of these components are environmental, for example, woodland within a is that better? Sorry. Woodland in the rural areas can be very, very important. Most of the rural populations rely on agriculture, and woodland can provide additional sources of income and sustenance for them. For example, from groundnut collection and bushmeat. And it can be very, very important in times of stress, for example, drought or flooding. If they lose their ability to farm these areas and collect incomes from this farming area, they can sustain themselves during this stressful period using this woodland instead. So that's one of the ideas that my research emanates from. There are other aspects of poverty as well. For example, international markets, government and things. They're not environmental or physical, but they can sometimes manifest themselves in environmental conditions. For example, if the international markets are demanding increased timber production in an area, increased timber in the market, you may find deforestation in a particular area. And if that particular area that woodland is sustaining poor people, there could be links there, and it could have an impact on these people's livelihoods. So my interest is to see if we can estimate some of these livelihoods from satellite data. But before that, we need to establish whether these links between environment and development actually exist in satellite data. So I'm going to illustrate it with a brief example from my PhD, which was conducted in Assam in northeast India. So the next two images I'm going to show you are in Assam, a couple of miles apart. The first one was a river island in the Brahmaputra River. And now this particular island, or this particular river system, I should say, is a very, very large system. And there's a lot of these islands all over Assam. And they're quite semi-temporary in nature. They will appear, and erosion, deposition, and flooding will mean that these islands will shift, they will change, and this island may not exist in a few years' time. But nevertheless, some people actually choose to live here and farm these areas. So this particular area down here that you can see is actually agricultural, and it's not that clear on the screen, but there are actually small dwellings there, and agricultural practices are going on. Now, these people are some of the poorest communities in India, in rural Assam and in rural India. And they locate themselves here through lack of other choices. There's no other land available for them. They don't have land rights in other areas, but they would rather live here and try and sustain themselves here than moving into the cities, into the slum areas of India. Now, in stark contrast to that, we move a few miles down onto the mainland, and we find huge differences. This is a wealthier area in Assam, and we can immediately see that there's a lot more diversity in this particular image. So we have agricultural land, but the fields are different sizes, different shapes. We also have different colours in the fields, which suggests that there's different cropping patterns occurring. In stark contrast to the islands, where we have one cropping a year, they try and get as much out of they can during the wet season for the rice paddies, and then often have to move on because there's no nutrients left until the flooding has occurred again that year. We also have in the wealthy areas woodland, and we also have evidence of roads, and with this area here, a suggestion that there's a small market or even education and things like that because it's a slightly more built-up area. So with this in mind, what we have is two distinct patterns using satellite imagery. Once you know a little bit about the local area, you can start to estimate, you can start to make a fairly good guess that the River Island community are probably going to be poorer with lower livelihood conditions compared to the people living in this sort of landscape pattern instead. And just to illustrate that a little bit further, this photograph taken from India, this was just outside of a wealthier village. Now, they quite often have good quality roads. Most of them in the rural areas will not be tarmacked, but they will be usable by public transport, which gives great access to markets and health facilities and education. They will also have extensive productive land. which they can use for generating their incomes. In contrast to that, this is a poorer area in Assam, not on the River Islands. Now, this used to be quite a wealthy area. A few years before I arrived, there was a flash flood occurred, and it deposited a huge amount of sediment over the agricultural land. Sorry, not sediment, it was sand, so it's not even productive, so it's basically buried their agricultural land under. There was estimates of up to 5 feet of sand deposited across this area. Now, this culminated in huge outmigration because most of the people there lost their livelihoods. So the poverty has now increased in this particular area. Outmigration has also increased. So the idea is if we can monitor and detect these changes from agriculture to bare land, grassland, sand, from satellite data, we may be able to start to say something about the local livelihood conditions. If we have, again, in the poorer areas, we have areas that do have agricultural land, we can find often that the plots of land that these people are using are smaller and they're ever decreasing because of population pressures. There's more people in these areas trying to use decreasing amounts of land through degradation and through and such like, and that forces people to move onto these areas of unsustainable, unsuitable land. For example, the plot here is actually right on the bank of a river which is known to flood very regularly and can cause huge destruction to the local communities. It could also mean if that's their only plot of land, this community using this plot could end up losing quite a large proportion of their incomes during the year. And they can as well, on the island they didn't have roads, we can find roads in these areas, but quite often they're not usable by transport. So the car there is the one that I was using, and we got to a point on that particular day, we could not go no further and had to go on foot instead. So it makes it very difficult for them to even have access to markets as easily as these wealthy areas. Now these patterns and these landscape and physical patterns on the ground mean that quite often you end up with spatial patterns of poverty occurring across regions. So this map here is a poverty map of type. It's based on female literacy because that was one of the only variables I had, but female literacy is strongly correlated with poverty, especially in rural Assam. So what we've got here is each of these points on this map is a village that I had data for, and the colours represent the literacy in percentages. So what we have is the dark reds are low female literacy or higher levels of relative poverty, and the green are higher literacy and lower levels of poverty. So before I went to Assam and fieldwork, I created these maps, and then I used these to direct my field visits. And what we found when we went, I specifically targeted going to this area here in the red, this area here in the green. And what we find when we get there is that the areas of red had these poor roads or no roads at all. There was very little woodland in these areas. They had no sort of small plots of land or no land at all, or they were even located on the banks of rivers or on river islands, compared to the green areas just right next door, which had some roads or better roads to get to markets. They had alternatives to agriculture available, sort of industry. They had a bigger biodiversity as well in that particular area. There was forestry available, there was agriculture available, and there was different types of agriculture available to them. So that leads me onto the remote sensing side. Now, remote sensing is basically a way of classifying satellite imagery based on reflectance of ground materials. Now, each ground material has a distinct, unique reflectance pattern, and we can identify these using remote sensing software. We can train the software to identify different land cover types. So the idea is if we can identify relationships between environmental conditions, landscape patterns and poverty, can we also find relationships using satellite metrics that represent these environmental and landscape conditions? So as an example, what we do is we would take the satellite imagery here, is that pretty dark, and what we do is in the field we collect information from the local populations about which land cover types, landscape types are important to their livelihoods. Once we have worked that out, we then look at the satellite data that we have and work out again what is possible to detect, and we come up with a classification which is an automated in the software. So what we have here is we have a few classes that were found to be important by the local populations. Now, the idea is how we would do this is using statistical approaches. We know where the village is located because we have a GPS point for each village from the census or from a household survey. So we would have a GPS point, say, for a village located on one of these river islands. And around that village, we create a polygon or some sort of shape to represent the area of land that village would most likely interact with. And then we extract the information from within that polygon, representing the local landscapes of that particular area. So, for example, what we're looking for then is we would use this in statistical tests to see whether the relationships in poorer villages have different relationships with their environment. You may find then, for example, what we're hoping for is that the poorer villages would be determined by lots of bare land, lots of water, and small amounts of agricultural land. And as you move into wealthier areas, you would find increasing amounts of biodiversity in that area and lower amounts of water and bare land. That's just one example of this. So my research at Columbia is going to be using the Millennium Villages data. And this is a fantastic data set for me to be using. It's a unique opportunity, really. There's 78 different villages in this data set. And during the course of the Millennium Villages project, we've had household surveys have been collected to look at the socioeconomic conditions from before the project started and then concurrently during the particular projects. Now, each time a household survey was conducted, that we have also collected some high-resolution satellite imagery, and this is on the screen as an example of the type of information that we can extract in the satellite information. Now, this is Potou in Senegal, and this image was taken from 2003, which was before the project started in this area. The following image is from 2011, so it's going to show you some of the changes in what's happened. Now, I just want you to look at the two boxes. If we look at the one on the right, first of all, we can see in the 8-year difference, can you see there? There's an increase in the number of dwellings, in the number of buildings that has appeared there, and the density of buildings has increased. And if we look at the left-hand side, the number of buildings hasn't really changed, but the actual reflectance of these buildings, the brightness of these buildings has changed, which suggests potentially that the building materials, the roofing materials has changed, which is quite an interesting result because we know from other literature that as wealth increases, as incomes increase in some rural communities in developing countries, they will change from vegetated roof systems to tin roofs as well. So the idea is to use this information, these changes over time, to see whether this corresponds to the changes in the satellite data, whether they correspond to changes in the socioeconomic data that we have in these household data sets. So why is this interesting and important? Well, it could be very useful for monitoring development approaches, such as the Millennium Villages project and the Millennium Development Goals. Now, currently, how this works is we would use household surveys, and these are really, really useful information because they give a lot of very detailed information on the socioeconomic changes over time. The problem is they can be very expensive to conduct, they can be time-consuming, and they can have relatively long time lags. Now, even a 3-year time lag can be fairly long if the socioeconomic conditions are changing in 6 or 18-month cycles. So we would pick up in the socioeconomic data what had changed, but we might miss why that has changed. So the strength of satellite data is that it's continually updated on a month-by-month basis. So because of that, we might be able to, if we can start to detect some of these changes over time, we could use the satellite data to inform us of where unexpected changes have occurred, or if we expect a change to have occurred and it hasn't, it could inform us that there may potentially be a problem. So, for example, the Millennium Villages, if we have a particular intervention that we expect to have an effect, and this effect occurs in the majority of the villages, but one of the villages does not change, the satellite data could identify that quicker. Rather than waiting for the 3-year household survey, we could see that these changes that were expected haven't occurred, and we could commission a new household survey to go and find out potential reasons why this has not or has occurred. So it would quite potentially has the power to support the household surveys and also to support the way that development assistance would change and monitor itself in the future. So some specific research questions that I'll be answering over the next couple of years. was looking at this, which particular land cover and land use metrics that we can derive from satellite data are actually related to socioeconomic conditions. And we also want to know if these relationships hold over time. Some of these relationships may only hold in one particular time period and then completely fall apart, so they're not really that useful. We need to know if they are robust over time, and also whether looking at change detection over time as well is a useful tool. And the final one is, can we identify community locations using the satellite data? This is really important, because at the moment I will be relying on knowing where the village is located based on the household survey, GPS information. If the community moves in that time period, we're looking at environmental changes, landscape changes that don't really matter anymore. So that is one of the big limitations so far that we'd have to look at in the future as well. Okay, that's it. Thank you.
Hi, everyone. I'm Nada Petrovic. I'm a second-year EEI fellow at the Center for Research on Environmental Decisions. This is Jamie Madrigano, who's the second-year fellow at the Mailman School of Public Health. And this is a joint project that we've been working on together that we'll be presenting. And it's one of the great advantages of this program that we've been able to do this interdisciplinary work together. So the title of our presentation is Perceptions of Fossil Fuels, Climate Change versus Public Health. So we all know that climate change poses a massive challenge for motivating the general public in the United States. And there's multiple reasons for this, of course. There's the perceived uncertainty of the science. There's the lack of personal effects that people feel related to climate change. There's the distance in space and time. However, one key way to mitigate climate change is to reduce the use of fossil fuels, and this has the added co-benefit of reducing health-damaging air pollutants. So a little bit of background on this. Fossil fuel burning emits particulate matter, ozone, nitrogen oxide. It increases heart disease, lung cancer, asthma, and other cardiac and respiratory diseases, and causes hundreds of thousands of premature deaths and lost life years worldwide. So because it's been shown in the behavioral literature that personal risk perception is a strong motivator of behavior change, it may be a good thing to try to emphasize these personal health effects. So additionally, public health effects are spatially and temporally much closer than climate change effects. So what we wanted to ask is, can a paradigm shift increase public engagement? This is a part of a larger project that Jamie and I are working on that includes both thinking about the risk perception as well as community engagement and policy analysis. And we'll talk a little bit more about the other parts at the end, but currently we're focusing on the risk perception component. The main research questions are, how does the public perceive health impacts of fossil fuel burning in comparison to climate change impacts? Do they feel that they are more certain? Do they feel more personally at risk and that they're closer in time and space? Does this increased certainty and risk perception lead to a desire to reduce fossil fuel use? Can this be used to frame fossil fuels in terms of public health? And why does this matter? Because this would give us the opportunity to tailor messages aimed at people who don't care so much about climate but care about health. The methods that we're going to present for this pilot study were an internet survey, an internet framing experiment that was done with 800 participants on an online community through Amazon. So this is a fairly representative sample, except it was quite liberal, and that may simply have to do with the types of people who choose to do these surveys. So in the next batch, we're going to try to selectively sample for more conservatives. So the first question we wanted to address is, are the effects to public health more certain than the effects to climate change? So we asked people to agree or disagree on a 5-point scale with the following two statements. The burning of fossil fuels emits carbon dioxide, which is a cause of climate change, or the burning of fossil fuels emits pollutants, which lead to health problems. As you can see on this plot right here, people did indeed feel more strongly that it leads to, that the certainty of health problems was greater. It was about 90% versus 80%. The numbers are high in general, again, because of the liberalness of our sample. And they felt less strongly about the climate change. However, something that we did not expect was that political ideology played a huge role not only for climate, but also for health. So on this plot right here, we have political ideology ranging from liberal to conservative on the x-axis, and then the mean agreement strength with the previous statements for health and for climate. Now, as conservatism increases, we see that the climate strength of agreement decreases. However, the same thing also happens for health. So this is not just, the certainty is not just an issue for climate change. It's an issue for a variety of scientific results related to fossil fuels, and political ideology has begun to permeate all of this. However, the good news is that the difference does increase with political ideology. So so the benefit of speaking about health to conservatives is still greater. We were also interested in spatial risk perception. So do people feel that health impacts are closer in space than climate change impacts? We asked them a series of questions about whether or not they felt personally affected by pollution from fossil fuels and health, and by climate change. We asked for themselves, their family, their community, US communities, and communities in other countries, so sort of increasing the spatial scale. Again, we found that people felt more personally affected by health impacts. So in this case, for self, for family, and for their own communities, about 10% more people felt affected by health impacts than by climate change impacts. And these were all significant differences. For communities in the US and in other countries, there was a much smaller difference, and there was actually no significant difference for other countries for these impacts. However, these spatial impacts were again highly influenced by political ideology. So we have a similar plot right here with political ideology on the x-axis and the fraction of people who felt personally affected on the y-axis. And we can see that this fraction goes down quite a bit with political ideology. Interestingly, when we go to the other spatial scale, so the effects in communities in other countries, this effect of political ideology largely goes away. And we saw a similar effect for the temporal questions. So it's interesting to me that political ideology has a lot of different ways of working through this process. It works through certainty. It also works through risk perception. Conservatives may feel that it's happening, but it's happening further away. So in summary, in general, public health effects are seen as more certain and closer in space and time. We actually didn't see as clear an effect for worry. However, certainty, worry, spatial and temporal risk perception were all heavily influenced by political ideology for both climate and for health. So this is not just a problem related to the specifics of climate change. This is a problem related to fossil fuels and how we think about fossil fuels and how this relates to ideology. However, the good news is that the effect was less for public health. So this implies there's some potential speaking to conservatives about public health issues. And Jamie's going to continue.
Okay, so just to continue on along those lines, as Nada mentioned, we saw that there were these differences in many different aspects of certainty, worry, spatial and temporal scales about how people think about the differences in how people think about the public health impacts from fossil fuel use and burning and the climate change impacts. We thought we would explore this issue of certainty a little bit more. And so as Nada discussed, we saw that political ideology influences how certain people feel about public health impacts of fossil fuel use as well as climate change impacts. And there's a difference in between those. It seems to impact climate change impacts more. We then wondered if how certain people feel about those impacts would be associated with their likelihood to say that they do think there should be a reduction in fossil fuel use. So we asked a question in the survey of whether people felt that there should be a reduction in fossil fuel use. So just to kind of get a visual look at our data, in that question, each of these points in this diagram represents a person's response to that question. And the answers were a 5-point Likert scale. And you can see that if you're yellow or red, you fall into disagree or strongly disagreeing with that statement that you believe there should be a reduction in fossil fuel use. And the blue categories are agreement or strong agreement. And then to orient you a little bit, the x-axis represents how strongly you felt that there are public health impacts of fossil fuel use, ranging from not strong one to highly certain. And then on the y-axis, we have the strength of certainty increasing as you go up in terms of what you think about whether there are climate change impacts of fossil fuel use. So in the upper right quadrant, these are people that feel both very certain that there are public health impacts of fossil fuel use and that there are climate change impacts. And then not surprisingly, we see a lot of blues in that category. So when you feel very certain that there are both of these impacts, you really think there should be a reduction in fossil fuel use. Again, not surprisingly, in the lower left quadrant, these are people that are very uncertain about that either of these impacts are happening. And we see, although a lot less people, as we talked about our sample, these people don't feel that there needs to be a reduction in fossil fuel use. So what we wanted to focus on a little bit more, and where we think there's potentially an opportunity to explore further, is this bottom right area, which are people that are not convinced about the certainty of climate change impacts, but do feel strongly that there are public health impacts of fossil fuel use. And in this category, we see a good number of blue dots. So that leads us to think that there is some potential to sort of working with that population. So then when we looked at that a little bit further, we looked at a model that included factors for how certain people are, as well as whether they were worried about these two types of impacts, and a number of other questions in terms of with the outcome of whether they actually felt that they had a desire to reduce fossil fuel burning. And we do see that the feelings of certainty about that these health impacts or climate change impacts are happening is significantly predicts whether you are likely to say there should be a reduction in fossil fuel use. We see that it's stronger for when people are feeling certain about the health impacts than for the climate change impacts. We also see that still political ideology independently is associated with a desire to reduce fossil fuel burning. And we saw some interesting associations with worry about these impacts, which we're still sort of looking into a little bit further now. So given all of this, we are wondering if we can actually use this information to inform messaging, to create better risk communication and potentially change behavior. So to look at that, we set up a framing experiment, which was a simple experiment, as Nana mentioned, conducted online. And the frame consisted of simple conditions of reading a participant was assigned to either the health frame or the climate frame. They would read a simple paragraph where the burning of fossil fuels was described as emitting air pollutants that either are harmful to human health and can result in a large number of deaths, or that fossil fuels emits pollutants that contribute to climate change and will result in dire environmental consequences. And then we asked a number of outcome questions, generally falling into two categories. We grouped them into categories of questions about people's beliefs and questions about willingness to take actions. So the beliefs questions consisted of questions like, do you feel a personal responsibility to reduce fossil fuel use? Do you feel that fossil fuel use directly impacts your well-being? And the actions questions were along the lines of, and those beliefs questions were on a 5-point Likert scale. The actions questions, many of them were a yes or no answer. For example, are you in favor of a tax on fossil fuel use? Would you be willing to contribute a donation to a charity that is advocating for renewable energy? And so with the frame and looking at the outcomes of the questions, we took all of the beliefs questions. They were in comparing to each other, there was a strong level of agreement, so we combined them, created an index, and looked to see if our frame made a difference. And it did not make a difference in people's beliefs overall. We still saw that political ideology was a strong predictor in people's beliefs. We broke that down a little bit further and looked at each of those questions individually. And for one of the questions, of all of them, we saw that there was an effect of the frame, and that was the question of the burning of fossil fuels directly impacts my personal well-being. So that could be potentially because of the wording of the question, where people associate well-being with health. In any case, that was the only question we saw an effect of the frame. When we looked at the effect of the frame on actions, again, we didn't see, this is just one example where we asked participants if they were willing to donate to a charity. We didn't see any effect of the frame on this question or any of the actions questions, so we saw similar results. And again, we saw that political ideology was a very strong predictor of whether participants were willing to take action in terms of fossil fuel use reduction. So from this preliminary work so far, we see that health impacts are perceived as more certain and closer than climate change impacts. However, both are heavily impacted by political ideology. Political ideology, certainty of, and worry about both of these types of impacts from fossil fuel burning are associated with a desire to reduce fossil fuel burning. But our message framing had a minimal impact on beliefs and no impact on willingness to take action to reduce fossil fuel burning. Consistently throughout everything that we've looked at, political ideology is a strong predictor of willingness to take action. And because it's associated with both certainty of climate change effects and certainty of public health impacts, we think that this may be one reason we didn't see an effect of the frame. It's just such a strong factor. So in future work, we're continuing to analyze this pilot data and thinking about how we might redesign the framing experiment to tease some of these things out a little bit more. And so certainly we're looking for feedback if anyone has thoughts. In the bigger picture, we talked about this as part of a bigger project where we're trying to take an integrated approach to climate and public health co-benefits. We're also working on some community engagement in a collaboration with a community or environmental justice organization that operates in West Harlem to look specifically at that community's perceptions and concerns about climate change and public health. And so we've met with that community organization and we're developing some plans with them. And in addition, we're planning to work on a local within New York City climate and public health co-benefits risk assessment. So again, working with that community organization known as We Act, which is an environmental justice organization here in New York. We're going to target specific New York City policies and initiatives that are of particular interest to them and their constituency, and assess how, what types of benefits and what policies might benefit that community the greatest from both a public health and climate perspective. So we just wanted to acknowledge the way, how we've been able to work on this project together through, of course, the Fellows Program and some funding we've received through the Cross-Cutting Initiative. Our mentors, Ben Orlov from CRED and Patrick Kinney from the School of Public Health. People that have provided a lot of insight and assistance in this project, Sabina Marks and Lisa Zaval from CRED. Danielle Smith, an intern research assistant that has worked with us from the college. And our collaborators from We Act. So thank you, and I think Jesse Lasky is next.
Hi, everybody. Thanks for coming today. My name is Jesse Lasky. I'm one of the new fellows also starting here, and I'm working primarily with Maria Uriarte in the Department of Ecology, Evolution, and Environmental Biology. And I'm going to talk about work that was primarily conducted before I came here as a PhD student at the University of Texas. And I'm going to start out talking about kind of broadly the kinds of questions that I'm interested in. And I come from an ecology background, and a lot of what I study is trying to understand how the spatial structure, the geometry of the landscape of the land affects things like biodiversity and ecosystem processes, specifically with an interest on things that provide services to humans. And on this first slide here, I'm just giving you an idea of the kind of variation that I'm thinking about in landscape structure, from something dominated by small fragments of forest to something with fewer and larger fragments. I'll come back to that in a second. I briefly want to acknowledge my co-author on this, who is my PhD advisor, Tim Kitt at the University of Texas. So the basic idea here is that humans affect landscape structure depending on a variety of actions that we pursue. And an example here are two different shots from Amazonian Brazil. One, the amount of forest preserved in these two landscapes may be roughly similar, but it may have really important consequences for organisms inhabiting those landscapes. Let me give you an example. As you move, so focusing on the landscape on the left, you can see there are many small fragments. So if you imagine that you are some organism, let's say some animal that lives only in the forest, you may end up having a relatively small number of individuals in your local population within your small little forest patch in that landscape. On the other hand, in a landscape where you have this much larger forest fragment, you may end up being able to move across a larger area of habitat, interact with a larger number of individuals, maybe a larger local population. Now, this has important consequences if we just think about something like stochastic population fluctuations. So if there are just sort of random processes of birth and death happening all the time, if you have a very small population within a very small forest fragment, the chances are higher that maybe this thing will go extinct in this little forest fragment than if it has a larger population in this larger fragment, where the larger population size to a certain degree buffers it against extinction because of random fluctuations. This is a kind of example of the things that I'm interested in. Now, so that's an example of the kind of populational changes that can happen. But we want to look and think about how does this affect the numbers of species that are found in these landscapes and the kinds of services that these forests might provide. And this question of how the spatial structure of the landscape affects diversity is one that dates back decades and is largely inspired by work by Robert MacArthur and Edward Wilson in 1967, the theory of island biogeography. And so it's really basic theory. The idea is, so here's a shot of the Caribbean. The idea is that as you look at larger islands like Cuba, you see more species. And when you look at smaller islands, like maybe the Virgin Islands out here, you see fewer species. And as you look at islands closer to the mainland, let's say Cuba, compared to something farther away like the Dominican Republic, you see fewer species farther from the mainland and more closer. And the idea is that larger islands have more species because they have a lower extinction rate from stochastic population processes, and they also receive more immigrants from the mainland. Now, in 1975, there was a big controversy started in ecology by Jared Diamond. And the basic question that you might face as a land manager interested in conservation is, you have a given budget of how much you can spend on land acquisition. Now the question is then, well, how do you allocate that? One basic question you might face is, do we allocate this into a single large reserve, one big park, or many small parks across the landscape? And this basic fundamental question has sparked a lot of controversy and still doesn't really have a great resolution. Diamond said that island biogeography theory says we should have one big reserve because we have less extinction and this will support more species. But most people who kind of followed up on that countered that island biogeography theory is not really predicting in this situation. Island biogeography theory doesn't predict the numbers of species we'll have across many islands. So the idea here is applying the theory of islands to kind of little reserve islands, to parks, or to small patches of habitat. And so there was a number of papers at the time, but there's some aspects of this that have really been overlooked. And more specifically, I'm referring to a sort of theoretical consideration of how an ecological community that is structured by environmental gradients and dispersal patterns of organisms may respond to these different kinds of strategies of one big reserve or smaller reserves. In this landscape here I'm showing you in Arizona, I'm just trying to illustrate the kind of environmental gradient I'm talking about. So if you look moving from right to left into the upper left there, that's the San Pedro River. And there's this very strong environmental gradient there of precipitation, or of, moisture due to the presence of this river. And you see this huge change in the kinds of organisms that are there, kinds of plants, let's say. So you have trees found all along the river basin and much different scrubbier vegetation outside of the river. So this is the kind of environmental difference as you move from riparian to upland habitat so this kind of a community, one that is structured by this kind of environmental gradient, has sort of been ignored in this debate over reserve size. It's really been kind of very abstract and not considering this aspect that we know is very important in many landscapes. The fact that environment changes in space, and so do the kinds of organisms that are found there. So the idea, sort of conceptually, is to try to consider this question of reserve size variation in the context of two different aspects of the reserve. And here I'm just showing you kind of idealized simulated landscapes. So on one hand, on the left, you have what I'm calling the effects of the landscape geometry, which is kind of what traditionally people have thought about. How do the size and the configuration of these landscape patches affect the communities? But at the same time, let's think about some environmental gradient that underlies this. Here, let's call it maybe elevation. So how does having different sizes of reserves across an elevational gradient affect this? Well, this can be important, this combination of both the spatial pattern and this underlying environmental gradient, because of something called source sink dynamics. And let me sort of show you what I mean here. So let's imagine a landscape down here. And in this landscape, we have two kinds of environment. There's red and there's blue. There's something different about the physical environment in those two locations. Now there's two species in this landscape. One specializes in red. The red species specializes in the red environment and has greater fitness there. The blue species specializes in a blue environment. Now, just because of dispersal, because these seeds, these trees are throwing their seeds across the landscape, you have a bunch of blue seeds landing in this environment where they're not the best species. The red one is better, but there's stochastic population dynamics going on, and just by luck, some of these blue species will recruit here and maybe grow up, and so you now have a forest with two different species. So this is a sink population here. This is what we call it. This is a sink population. The reason why it's a sink is that it wouldn't sustain itself without dispersal. Without these seeds arriving here, this blue species would die out. Now this is key because the way in which you fragment a landscape, the way in which your reserves, for instance, are laid out, really can have a strong impact on dispersal, on the ability of seeds to move around. Let me show you what I mean. So let's just look at two landscapes now. On the left, we have a landscape where the grain of environment is very coarse, meaning that if you're looking at a cell here that is in the red environment, its neighboring cells are all red also. So it's a very strong spatial autocorrelation in the environment here. On the right, you have a very different kind of environment. There's much finer grain variation, lower spatial autocorrelation. And so in this situation, we have those seeds arriving from other environments. So these blue environments are supporting populations of the blue species that send their seeds over here. And that's not happening here. This cell of red environment is surrounded by other red cells where you have all of the red species. So this is a very different distribution of diversity. The question is, when these kinds of things are happening, which we think are relatively common in real environments, what happens when you start losing environment? What happens when you start losing habitat where nothing can be located? And I want to make the point that this has some pretty important implications for ecosystem services. Because, for example, here, if we look at the blue species, it doesn't perform as well in this red environment where it's a sink population. So it has less productivity and likely also would provide less carbon storage, for example. And so the ability of forests to support or to store carbon can be very important in terms of mitigating the increase in CO2 emissions. And so the kinds of decisions we make about how to manage landscapes may have cascading effects on how much carbon is stored in this manner. So the expectation here, or the main the expectation is that when we have small reserve systems, so up here on the top, where we have many, many small reserves, we're going to have less of these source sink dynamics. And so the effects that these source sink dynamics have on diversity and on ecosystem productivity will be important. And so to give you an idea of the kinds of landscapes I'm comparing, there's the small and the large to show you some real landscapes. And I'm going to go a little bit quicker through this. This is just an example of how the simulations go. The main idea here is that we have all these different species that each specialize in a different kind of environment. And then we allow them to disperse across the landscape. And the easiest way to sort of communicate how this plays out is to, I think, show an animation here of how this works. Okay, this is easier, so now I can point. So the idea is, on the left here, we have these small habitat reserves. All these white cells are habitat reserves. Here on the right, we have this very large habitat reserve. If you look here on the left, these smaller cells end up being dominated by a single species. So we're showing over time different species. This is because there's not a lot of dispersal across different reserves. So you don't have sink populations. You don't have sort of this stochastic turnover in the community that is much more common in larger reserves here. You see much more mixing of the species here. And so actually, if you were to look, if you were to go into a forest like this and stand up and look around you, you're going to see more species coexisting together in a single location, as opposed to going into a small reserve on the end there. So to show you what that looks like in sort of the static shot, in all of these small reserves, we have these very clustered populations. And so we have this low level of diversity in the small patch. But in these larger reserves, we have this greater spatial mixing of species. This is also changes the level of productivity. And this is a simulation, so these are numerical simulations of a kind of idealized forest. But in this simulation, this changes the productivity and carbon storage of these forests. So in this example, in this kind of landscape of large reserves, you end up having many more species that are sink populations living in environments next to source population species. And so those sinks are of lower productivity and would store less carbon. So to sort of summarize what I was looking at there, we see across these landscapes of smaller reserves, I didn't get into this a ton, but there's greater numbers of species stored across these landscapes. They're more strongly structured by environment, and they have greater productivity or carbon storage, if you want to think of something with important applications. In these larger reserves, we see greater turnover over time and space of species, which can be important for providing other services. So just in summary, this is a very idealized community, but we do see some of the potential reserve size effects on communities in terms of their diversity and services. They're not meant to support a single strategy of conservation of reserve size design. However, it's an important consideration that these source sink dynamics can be affecting diversity and services. And so I just want to thank my advisor and other people. And and I'm going to introduce Josh Fisher. And Josh comes to us from George Mason, got his PhD there, and has a lot of experience outside of academia as well. So here's Josh.
So I'm Josh Fisher, and today I'm going to be presenting work that I'm currently conducting in the Peruvian Amazon on conflict-sensitive natural resource management. Before discussing my research, I'll say just a brief bit about myself and my interest in sustainability. So I'm a postdoctoral research scientist here at the Earth Institute at the Advanced Consortium on Conflict, Cooperation, and Complexity. I'm also a lecturer in the Negotiation and Conflict Resolution Department, where I teach graduate courses on environmental conflict resolution. And the questions I explore through both my academic and my professional work, they revolve around social relationships in and with the natural world, looking specifically at how we manage natural resources to encourage cooperative, peaceful, and sustainable systems. My previous work has looked at agroforestry, fisheries, and protected area management in Mozambique, as well as land use planning and impact assessment for natural gas and oil development on public lands in the western U.S. Currently, I'm looking at forest governance and natural resource management in the Amazon, and the project I'll describe today is part of that. So the tropical Andes biodiversity hotspot, identified by Conservation International, is one of the most biodiverse and ecologically important areas in the world. And it runs from Venezuela and Colombia along the western side of South America down through Argentina and Chile. The hotspot contains an estimated 30,000 vascular plant species, of which 15,000 are endemic. In terms of fauna, the tropical Andes is incredibly diverse, with high rates of endemism for reptiles, amphibians, fish, freshwater fish, and birds. In addition to the high endemism, the hotspot's the last bastion of habitat for a large number of species. Of the 75 endemic mammal species in the tropical Andes, 70 are threatened. Likewise, of the 600 endemic bird species, 160 are threatened. Inside the tropical Andes, the Peruvian Amazon, specifically the Andes-Amazon interface, outlined in red, is home to some of the Earth's richest and most diverse forests. The region holds multiple types of forests, lowland forests and cloud forests, that extend on an elevation gradient from 500 to 3,500 meters, or 2,600 to 11,500 feet. Like the rest of the hotspot, the forests in the Peruvian Amazon have exceptionally high rates of endemism and provide a wide range of ecosystem services on local, regional, and global scales. In addition to the incredible biodiversity, the forests in the region have high economic value. These forests have some of the world's richest reserves in gold, copper, lead, and zinc. Additionally, the vast standing forests in the Amazon were recently connected to global markets by the completion of the Trans-Amazon Highway running from Brazil to the Peruvian coast. So for a country with 31% of its people below the poverty line, and with resource extraction and manufacturing comprising 38% of its GDP, the resources in the region are vital to national economic development. Aside from the economic value of the forest, they're incredibly important for preserving social and cultural values in Peru. For instance, there are an estimated 15 uncontacted tribes or tribes in voluntary isolation in Peru. And the expansion of mining, logging, agriculture, and mineral exploration presents a real and a viable threat to these groups. So the spatial intersection of these various factors creates a highly complex social ecological system, and balancing the needs of biological conservation, economic development, and cultural preservation is incredibly difficult. Finding that balance is so difficult, in fact, that these competing pressures combine to produce low-level conflict across the region. There are increasingly frequent reports of mass demonstrations, violent protests, and occasional killings in the region. In March of this year, for example, between 8,000 and 10,000 demonstrators took to the streets in Puerto Maldonado, protesting legislation that would restrict illegal mining. Ultimately, that demonstration alone resulted in 3 deaths, 48 injuries, 66 arrests, and the deployment of 800 officers to restore calm. Additionally, conflicts between corporate interests, informal miners, and citizens opposed to mining projects are on the rise. One estimate by Oxfam reports that there have been over 240 conflicts related to mining in Peru in recent years, with violence perpetrated against indigenous groups and civil society organizations. So considering these competing pressures, the question I'm interested in is how to manage Peruvian forests in order to maximize conservation, cultural, and economic gains. The answer, of course, is that there isn't one single management strategy capable of accomplishing all those goals, and in fact that different areas require different management strategies. An interesting model, and one that's seen real success in maintaining ecological integrity in the Peruvian Amazon, is the model of conservation concessions. In 2000, Peru introduced legislation enabling non-governmental actors to establish large tracts of state-owned lands as conservation concessions, thereby managing what would otherwise be de facto unmanaged forests. And a government agency called by the acronym IRENA oversees the concessions. The process of establishing a concession involves an NGO submitting a technical proposal and then preparing a management plan with a long-term investment commitment. The award process involves multiple public consultations with private stakeholders as well as indigenous groups, local communities, and regional authorities. And a successful concession application is followed by a 40-year concession award, wherein concessionaires are required to periodically update their management plans to adaptively respond to changing management challenges. So in 2001, the US-based Amazon Conservation Association and the Peruvian-based Asociación para la Conservación de la Cuenca Amazónica established the world's first private conservation concession in the Peruvian Amazon, and it's called Los Amigos. This concession manages 360,000 acres of old-growth Amazon forest in southeastern Peru. The goal of Los Amigos is to ensure lasting protection of the Los Amigos watershed, create sustainable economic and social benefits for local populations, and empower a new generation of Peruvian resource managers. Importantly, in line with Peruvian law, ACA and ACA are currently beginning the process of reviewing and updating the Los Amigos management plan. However, the concession's at the forefront of the multiple challenges I discussed earlier. Namely, there's increasing pressure from illegal mining and logging on the peripheries of the concession, and trespass and illegal cutting are increasing forest conversion and degradation at an alarming rate. Likewise, there's tension between resource managers and local communities surrounding issues of resource extraction and conservation on traditional lands adjacent to the reserve. So, in addition to managing Los Amigos, ACA and ACA work directly with indigenous groups in the area to develop conservation management plans for their traditional lands, and they support them in livelihoods generation projects. So in all these conservation efforts, the question continually arises how to develop management strategies that limit the costs of conservation on local communities and stakeholders, while taking sufficient measures to safeguard ecosystem health and functioning. The question's more salient when considering that conservation and resource management decisions in the area frequently fuel grievances for various stakeholders and contribute to conflict dynamics across the region. So under an Earth Clinic grant from the Earth Institute, my research team and I are partnering with ACA and ACA to try to answer that question by employing applied and empirical research in the Peruvian conservation concessions. Our project will employ the conflict-sensitive conservation methodology developed by the International Institute for Sustainable Development to identify the drivers of conflict in and around conservation concessions, and then identify opportunities for informing concession management plans to mitigate those drivers through socially informed resource management. And the CSC methodology was originally developed to assist conservation organizations that operate in high-level conflict zones by identifying the impact that conservation has on the conflict, and also by conducting conflict sensitivity trainings to help conservationists operate in the conflict. My team and I are currently working to adapt this methodology to the low-level conflict situation in and around concessions in Peru, where conflict may or may not be violently manifest, but where conservation strategies definitely affect social relationships in the area, and thereby social stability across the region. So our project consists of two components. The first component is applied research that aims to bring stakeholders together to identify the latent as well as the manifest drivers of conflict in the area. The first component also aims to identify potential entry points and concession management plans for conflict-sensitive management strategies, and to enhance concession managers' ability to productively interface with stakeholders around contentious issues. The work plan for the first component consists of 4 activities. The first activity is a scoping phase, which will be used to identify potential stakeholders and issues, generate pre-intervention baseline data, and inform subsequent phases of the work. The second activity involves a series of conflict analysis workshops that will engage stakeholders and concession managers to prioritize issues and to identify entry points for conflict-sensitive management. The third activity consists of conflict management trainings to build capacity among conservationists to engage stakeholders on contentious issues. And the fourth activity involves incorporating social considerations into updated concession management plans. And so then the second component involves empirical research that will assess the effectiveness of that intervention according to the following 4 hypotheses. First, conflict-sensitive conservation and programming and management increase voluntary compliance with protected area rules and laws among stakeholders. Next, administering conflict-sensitive training reduces the frequency of verbal and physical confrontations among conservationists and other stakeholders. Third, conflict-sensitive conservation programming increases the reach and effectiveness of livelihoods generation efforts. And finally, incorporating conflict sensitivity into conservation programming can mitigate the adverse impacts of conservation on local stakeholders in and around the concessions. And the work plan for this second component consists of 3 activities. The first is a midterm evaluation after the initial trainings and workshops to assess conflict levels against the pre-intervention baseline. The second activity is a final project evaluation of 1 year from implementation to assess the initial impacts of the intervention against the baseline. And then the third activity involves disseminating knowledge generated through the project in peer-reviewed publications and leveraging the initial results to pursue follow-on funding to refine the methodology and scale the project up. So we're currently finalizing the work plan with our partners at ACA and ACA in order to begin the scoping phase, and we're also generating pre-intervention baseline data. We should hold our first set of stakeholder workshops in Peru in early May at the end of the rainy season when the area becomes accessible again. And from there, we'll work with concession managers to identify potential updates to their management plan. And we'll also begin preparing for the midterm evaluation. The project's currently funded for 18 months with a possible 6-month extension. So we'll conduct a second set of stakeholder workshops in May 2014 to evaluate the project after 1 year. And then we'll conduct the final evaluation. And we hope to have everything wrapped up by June 2014. And so I'll just end by saying that the Earth Clinic, which funds this project, is intended to serve the immediate needs of clients in developing countries who are facing pressing economic and environmental problems. And the purpose of our project isn't to prescribe solutions for concession managers and stakeholders. The purpose is not to impose a solution. Rather, the project hopes to provide a collaborative framework in which these groups can work together to understand the impacts of conservation on conflict dynamics in the region, and then identify opportunities for adaptively responding to those impacts in order to generate greater conservation gains and peaceful and productive relationships among the stakeholders. Thank you.
So thank you all the speakers. We're a little bit behind schedule, but I will give over the time I was going to take for my extensive closing remarks in order to make sure there's time for questions. So questions can be asked of any of the speakers. I realize this requires that you remember what the earlier ones said, but please ask questions of anybody. Lex.
Sure.
Yes.
I liked your presentation about the Assam work. I think I understand where you're going with the work in Millennium villages, but I was missing a big question. I think it's work. So you know, fairly or unfairly, the Millennium Villages project has been criticized because of a lack of control. So if you compare some of your roof analysis with on-the-ground surveys and you show that works, I could imagine that you might be able to provide some controls by looking at images of villages where the Millennium Village project has never been. Is that something that you're considering?
Yes, that is something I've been looking into because of the controls. The idea would be to look using satellite data to actually use the data to focus on where we would go to identify that as well. So, but it's not really I'm not trying to validate our Millennium Villages projects using this satellite data. It's more just using the information that's being collected to monitor these changes.
See, you've only got 2 years.
My name is Jasper Jongtambia. I have a background in, I have an MBA in finance. I'm a financial engineer. I have a question. The first presenter, you could have the best technology. If it doesn't cost to the effect of the people, it's hopeless. So what can you do from the studies you are conducting to show that the technology you are having is going to have, going to implement it in India, considering the economic factor in that country?
Are you volunteering to answer the question? Oh. Sorry. You have to stand there.
So I enjoyed all these presentations. They were terrific. So a question for, well, I guess maybe quickly a follow-up to Lex's comment on Gary's talk, and that is, I'm not familiar with the Millennium Villages projects, but one thing that would be interesting to know would be not just the control issue, but also whether there's kind of a spillover effect. So even areas outside may be picking up some of the benefits of the investments within the villages, something to look for. And then for Jesse, in the biogeography area, one of the issues, as you know, has to do with putting all your eggs in one basket, as it were, right? This idea of uncertainty and catastrophe, and the way you were modeling the ecosystems, the landscapes, is very similar to what we see in the social sciences, something called agent-based modeling. It actually looks the same. In the pictures you showed us, you had the same distribution of species, irrespective of the geography. In other words, even when you had just the little patches, you had the same species as in the larger ecosystem. And obviously, there would be potential for extinction if you were to shrink the habitats. You would, right, minimum viable population, for example. But the other thought I had was about if you had an infectious disease that were to enter, because then the argument for having separate ecosystems would be supported. And there's a lot of interesting work in this literature on agent-based modeling on infectious diseases. In fact, I think that's some of the best work in agent-based modeling. So I was just wondering if you had thought of that.
Yeah. So I guess one of the things that I haven't done this myself, but there is in the literature a fair understanding of that the sort of spatial pattern, the contagiousness of disturbances can have a major impact on whether or not large or small reserves are preferred. This is what you were getting to. So when you have disturbances occurring in sort of very large continuous areas, this can support or contagions, infectious agents. Those kinds of processes that are very highly spatially autocorrelated can support having many smaller reserves across an environment. I think that's the main thing you're getting at. I think also whenever we compare the small and large reserves in my study here, the overall picture that we see in terms of community composition, where species are found, is similar across the different ends of the spectrum of reserve size, but there are many things that vary on top of that. How many of those species actually survive? So we see in some of the larger reserves, we end up seeing greater extinction rates of things that are kind of marginal species that only perform well, that are specialized in rare environments because they end up getting pushed out by sort of average, the best species. And that's another benefit that you can actually have by separating things into smaller reserves, is that things that specialize in sort of rare environments are less subject to this competition from things that are sort of better on average. And yeah, the agent-based modeling literature would definitely be good to take more look at. Thanks.
Thanks. Sorry I had to be running in and out for phone calls. I apologize. Astrid? Where's Astrid? Yeah, thanks. Can the group in those experiments bind themselves to an outcome? And is that a kind of treatment that you can explore? I mean, it seemed the positive side seemed to be that in that experiment they could figure out what should be done.
They knew what should be done.
Right.
So they knew what should be done. They understood the game. They understood everything. The announcements were non-binding, and they knew that they were non-binding.
And after the play, was their play revealed, by the way, to others?
No, it was a one-shot game. I mean, we played a game about catastrophe. So once you had catastrophe, you played the game, and that's it. So it was a one-shot game. But we had practice.
But when you played it, did they know that afterwards it's going to be revealed who did what, even though I understand in the spirit of the game?
No.
Because it might be embarrassing for someone to have lied and so forth.
And they meet again next day on the campus. So
right.
You can't do that. No, it was anonymous. So
anonymous.
The players had letters. So they played through the computers. They had letters. They could see the letters. They could see the announcements, the action. But when they saw the faces after the experiment, they couldn't say who did what.
Because it does seem to me to be an important question of whether this is really the driving issue. Real play is not anonymous. Within, this climate change issue is a global issue where there isn't necessarily a binding mechanism, although there could be binding mechanisms. Or close to binding mechanisms. The problem hasn't been we're not going into treaties because we fear that someone else will cheat on the treaty. It's that we don't want to agree on the treaty, I would say. Many countries say we don't want to have a binding agreement. So that's a little bit different, and it would be interesting to do this in a context where the play is going to be revealed and they know it.
It has been done.
Okay,
yeah.
The same thing.
Well, not this same thing,
yeah.
But it has been done by other people. So if you have, for example, smaller groups, face-to-face communication, and you let them know who did what, then the argument is different. Because you remove basically all social distance.
No.
So you remove any social distance, and the outcome is different, that's true. So all players who can communicate face-to-face, they manage sometimes to have an agreement, a verbal agreement that is binding for these 4 people. But I don't know if climate negotiations really have no social distance, because it is a global problem, and if one country makes a pledge, I don't know if there is a face that stands for this one pledge. So I would say there is social distance for a problem like climate change. There are other problems.
I think it would be interesting to, maybe if you're saying it's, well, I think it would be interesting to look at this, because I'm not sure the social distance is really so high, or the notion that that one can't bind oneself through formal commitments is so difficult. We live in a world where it's very hard to negotiate treaties, but they're not broken completely willfully once they're negotiated. The big problem in the climate environment is countries don't want to bind themselves, which is a different kind of problem, it seems to me, and one worth understanding. So if you set up a circumstance where they could bind themselves and choose not to, that would tell us something. We want to reserve the opportunity to cheat or free ride, or we don't believe in it, or for whatever reason we're not ready to do more. Or, as in the climate negotiations now, the poor countries say the rich countries should do it, and the rich countries say we don't want to do it until everybody does it. So it's a matter of argumentation about responsibility, cost sharing, and so forth. But my own view is, I'm probably different from Scott's on this, that treaties are actually real to an important extent. And so there is a mechanism that can make a difference.
Yes, I agree, they are important, but the question is, are they really binding? I mean, is Kyoto really binding? Has it been binding for everyone?
Yeah, I think it's the reason why the U.S. never ratified it, because they didn't want to be bound by it. And so it's not, you know, the U.S. also is a very distinctive actor in this. The U.S. is the one person who says we'll play and then cheats. It's the biggest actor, and it has been the biggest deal breaker of everything. But we didn't come close to ratifying Kyoto because we don't want to be held accountable for breaking a treaty or breaking a protocol. If it were free and cheap, we would have done it to make everybody happy and then said, oh, it's very hard, we're not going to live up to it. Of course, Canada did that, but did that because the big neighbor is so reckless that they can get away with anything. So I do think that there's really an issue here in general with the prisoner's dilemma, which is that there are ways to overcome it through social distance or through law, contract, or that are not perfect but are not simply anonymous play. So it's something in between.
Should I take this thing? So this is interesting. Yeah, we'll definitely have a different view. What Astrid presented, I think, is quite astonishing because it is utterly consistent with everything we're actually seeing. So it gives us a way of interpreting what we're seeing. Why the negotiators would like to have this scientific view of dangerous climate change, why they would make proposals for everyone to do a lot, and be sincere about it, by the way. Why they would make pledges. The pledges don't add up to the proposals, and why the prediction is when they go home and they decide to adopt legislation, they actually don't do very much. I think it's utterly consistent with that. And I think it's true that what the United States did makes it difficult for other countries like Canada to engage, in a very serious way, but it's also true that the behavior of the United States, Canada, Japan, virtually every country I can name, including Europe, is also consistent with everything we understand about the limitations of international law. And the basic problem is the one you mentioned, which is this difficulty of making any kind of commitment binding. You can't do that. Now, I think the positive lesson of this research, which is what Astrid ended on, is that if there's another way, if you could negotiate about things that are a little bit different about the same problem, then you might be finding some leverage that you're losing with an agreement like Kyoto. So I think there's a positive message in this, which is that if we go about it a different way, we can have more success. But I think, I think the first lesson is to know why things have gone wrong. And then once you diagnose the problem that way, then you could propose a treatment that really gets at the root cause of the problem.
I think the argument has not been, the main argument hasn't been, we won't join a treaty because we can't be sure it's binding. The argument has been, we don't want to join a treaty because it's not binding on you. So the U.S. says we will join a treaty only when China wants to do what China says we don't want to do it. It's not part of, we're not required to, and so forth. So it's a little bit different from not having that instrument available. It's really a matter of arguing about distribution, relative costs, burden sharing, and different beliefs in the whole thing. So I think the results are very good, but I'm trying to get to the nub of the difficulty.
I think everything you said is true, but of course, what you're looking for is what's the real thing, the biggest thing that's holding everybody up. The last comment I would just make about this is what's happening here with this catastrophe is that the enforcement is coming from Mother Nature. If you cross that line, Mother Nature will ensure that you're going to suffer terribly, and because you know that, you avoid crossing the line. And the problem is we don't have the equivalent. We haven't been able to stitch together the equivalent to hold countries together. This is why, in this agreement, when there is the threshold, and it's certain, everyone knows what to do, they fall in line, and they would never regret their decision. They would never look back. Whereas, in the situation in which we don't know where the threshold is, all of that just collapses. And I think that does represent a problem, and we therefore want to find, well, we can't have a threshold from nature that we know about, that's certain. Can we make up something else that has the same effect on changing incentives?
I agree with that. If we knew for sure, we would do better. And that's an important part of the findings. But there's something more to it, that there's a deep asymmetry of the actors, which is not shown in this. Yeah, no, anyway, I think we are.
So I'd like to move the venue of the discussion and not close the discussion, but we have a reception in the Sat-Out room, which is literally downhill that way on the same level. Before that, I'd like to thank all of the speakers and to tell you that sometime in the spring semester, we'll do this again with a different group of postdoc fellows. You've seen a little less than half of them this time. We do it twice an academic year to show you these fine people we have. I'd like to thank Flora for the organization. Thank you very much. I'd like to thank Jeff, both for coming and to make sure you know that it was at his initiation that this program exists. And now 10 years ago, I suppose. I haven't tracked it back, but something like 10 years ago. So maybe we'll have a celebration next time. All right, thank you all very much. Thank you.